Hello, Matt here from chemistrystudent.com. In this video, we're going to look at the formation of alkenes from halogenoalkanes in elimination reactions. We're going to talk about why and how these reactions happen, outline the reaction mechanism, and look at how the conditions used determine the products formed. Other reactions and mechanisms of the halogenoalkanes, including nucleophilic substitution, have been covered in separate videos. Check the links in the description below. Before we talk in detail about the reaction, there are a few essential ideas you need to be comfortable with. Halogenoalkanes, also called haloalkanes, are a group of compounds that contain an alkyl group, carbon and hydrogen chain, bonded to a halogen, fluorine, chlorine, bromine or iodine. In simple terms, they are like an alkane where a halogen has taken the place of a hydrogen. Apart from with iodine, the carbon-halogen bond in a halogenoalkane is polar due to the halogen's high electronegativity and carbon's low electronegativity. This polarity leaves the halogen with a partial negative charge, and the carbon it is bonded to with a partial positive charge. As halogen size increases down group 7 from fluorine to iodine, the covalent bonds they make to carbon get weaker. This means a carbon-fluorine bond is very strong and has a very low reactivity. A carbon-iodine bond, however, is much weaker and more easily broken, making iodoalkanes quite reactive. Alkenes are unsaturated hydrocarbons that have a carbon-carbon double bond in their carbon chain. An elimination reaction describes a reaction where a pair of atoms or groups are removed from a molecule, leading to the formation of an unsaturated compound with a double or triple carbon-carbon bond in. A polar bond or molecule arises when electrons aren't evenly distributed between bonded atoms. One atom will have more electron density around it than the other, giving it a partial negative charge. The atom with less electron density around it will have a partial positive charge. The greater the polarity of the bond, the more the electrons in it are unequally distributed and the weaker the bond becomes. In organic chemistry, we showed the possible steps occurring in a reaction by using mechanisms. Curly arrows are used to show how a pair of electrons move as bonds get broken and formed. An arrowhead always points towards where the electron pair is moving to. Recap done, let's go. Halogenoalkanes can react with hydroxide ions in ethanolic conditions to form an alkene, water and halide ion. Hydroxide ions usually react as nucleophiles in organic reactions, as they have a lone pair of electrons. In certain conditions, however, they can be forced to act as a base and accept a H+ ion, forming water. When acting as a base of a halogenoalkane, a hydroxide ion takes a hydrogen from the carbon that is next to the carbon bonded to the halogen. At the same time, the carbon-halogen bond breaks, producing a halide ion. The pair of electrons from the carbon-hydrogen bond that got broken move to form a pi bond with the carbon that was bonded to the halogen. This forming of a pi bond creates a double bond between the two carbon atoms. All these bonds get broken and formed pretty much at the same time, making it a very busy one-step mechanism. A hydrogen and halide have been eliminated and removed from the halogenoalkane, and an unsaturated compound, in this case an alkene, gets formed, making this an elimination reaction. In order to force the hydroxide ion to act as a base, the reaction must be carried out in ethanolic conditions, and heat is needed to start the reaction process. The problem is ethanol and many halogenoalkanes are highly volatile, meaning they easily turn into a gas when heated. This means as soon as you heat up the reaction mixture, they would vaporize and leave the mixture as gases before the reaction has a chance to finish. To prevent this from happening, the reaction mixture is heated under reflux. A condenser is placed vertically above the heated mixture to cool and condense any vapors that form back into liquid. Gravity then forces the liquid to go back down into the reaction mixture. This ensures no reactants or products are lost. As ethanol is highly flammable, the mixture should be heated using an electric heater or water bath, never directly with a naked flame. If the reaction is carried out in water, so aqueous conditions, the hydroxide ion wouldn't act as a base but would act as a nucleophile and instead bond to the carbon from the carbon-halogen bond, producing an alcohol. This would be a nucleophilic substitution reaction and has been outlined in a separate video. Check the links in the description below. Sometimes, even with ethanolic conditions, some nucleophilic substitution can still occur, and a final product mixture can sometimes contain small amounts of the alcohol because of this. Let's have a quick recap of this mechanism using 2-bromopropane and sodium hydroxide as an example. A concentrated solution of sodium hydroxide in ethanol is heated under reflux with 2-bromopropane. A hydroxide ion takes a H+ ion from a carbon-hydrogen bond on carbon 1. As this happens, the carbon-halogen bond on carbon 2 breaks, producing a bromide ion with a new lone pair of electrons. The electron pair from the carbon-hydrogen bond that has broken moves to form a pi bond between carbon atoms 1 and 2, creating a carbon-carbon double bond and forming an alkene. A molecule of water, H2O, is also produced as the hydroxide ion accepts a H+ ion. So, to summarize, halogenoalkanes can undergo elimination reactions and form alkenes when heated under reflux with hydroxide ions in ethanolic conditions. Hydroxide ions act as a base and accept a H+ ion from a carbon that is next to the carbon bonded to the halogen in the halogenoalkane. As the carbon-halogen bond breaks, the electron pair from the carbon-hydrogen bond moves to form a pi bond with the neighbouring carbon. This forms a carbon-carbon double bond, and the product is an alkene. A molecule of water is also produced from the hydroxide ion accepting a H+ ion, and a halide ion is released. The reaction is an example of an elimination reaction as two groups, substituents, are removed from the halogenoalkane, forming an unsaturated compound, in this case an alkene. The specific conditions used, heated under reflux and ethanol as a solvent, are needed to ensure the hydroxide ions act as a base. If the reaction was carried out with water, aqueous conditions, nucleophilic substitution would occur and an alcohol would likely form. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.